Alright, so here we are with Unit 9, Lesson number 5, and we're going to talk about something called the hydronium ion. A hydronium ion, which has the formula H3O, so let me write that here. The hydronium ion is H3O with a plus. And a hydronium ion forms when two water molecules collide with each other. So you have one water molecule and another water molecule. When they collide with each other, what sometimes happens, doesn't happen very often, is that an H from one of the water molecules transfers to the first water molecule, and you end up with an H3O with a plus, and you end up with an OH minus. This is the hydronium ion. That's, of course, a hydroxide ion. And it is actually this ratio, the ratio of the hydronium ions to this hydroxide ion, actually tells you whether you have an acid or a base. If you have an equal number of these, which you would in a pure sample of water, then the pH is exactly 7. It's neutral. What makes a solution acidic is that there are more H3O pluses than OH minuses. The larger the difference, in other words, if you have a lot of H3Os and a few of these, you have a very strong acid. If they're very close but you only have a few more H3Os, you have a weak acid. The opposite would be if you have a lot of OHs and very few of these, you have a very strong base, so the pH would be up near 14. If these were close but you had a few more OHs, it would be a weak base and the pH would be somewhere around 8. That pretty much, this relationship, or the concentrations of these two ions, is what determines if something is an acid or a base. So a hydronium ion is simply just an H3O plus ion that forms when water molecules collide with each other. And that's basically what they are going through this long explanation right here. I'm not going to go through that whole explanation, obviously. A couple of things to talk about when it comes to acids before we get into this, and this will come into play a little bit more at the end of this unit. Of course, all Arrhenius acids have H written first, right? Oops, sorry. All Arrhenius acids have H written first. But you can have different kinds of acids. You can have what's called a monoprotic acid, which would be, for example, HCl, like you have here. When this splits in water, when it is put in water, it splits into one H plus ion and one Cl minus. It's monoprotic because it has one H in the formula. A diprotic acid, like H2SO4, splits into two H plus ions and an SO4 with a minus 2 charge. It's diprotic because it has two H pluses in it. And then, of course, there's triprotic acids, and I'm not going to go through this whole thing here. It has, three H's and a PO4 with a minus 3. This is really only interesting, and then you're not going to see these terms on the Regents exam. The only time that this comes into play, and you need to remember this, is when you have to do what are called titration problems, which is part of the last lesson or two in this unit. But that's basically hydronium ions. Let's move on to Arrhenius bases. Now, we already went through Arrhenius acids. Arrhenius acids, of course, have OH in it, and they're pretty simple to identify. There's nothing really that's going to confuse you. Arrhenius bases can be a little bit tricky because there are compounds that have OHs in it that are not Arrhenius bases. So basically, an Arrhenius base is any compound that has an OH at the end, as long as it does not, and this is important, does not contain carbon. Very important point, because there are compounds which are called alcohols that look like Arrhenius bases, but they are not. So basically, all Arrhenius bases have a metal with OH at the end. So NaOH is a very common base. It's on your reference tables. Calcium hydroxide is also. Notice they all end in hydroxide because that's what the name of OH is. One rule, excuse me, is ammonia. Ammonia is still considered to be a base, but it's not an Arrhenius base. It would be considered a base if we looked at the alternative. And you can also have mono and dihydroxy bases. Not really crazy about this, worrying about this, but I'm going to go through it anyway. And I think you probably figured it out. A monohydroxy base is a base that has one OH in it, and it's going to break apart into the metal ion and the OH minus. And this is what makes it a base, because it splits into that. This would break up into calcium plus 2 and then 2 OH ions. Notice that the plus 2 would be canceled out by the 2 negatives. And then a trihydroxy base would break apart into an aluminum ion and then 3 OHs with a minus. The negatives and positives still cancel out. Plus 3, and then you have 3 negatives. And that is, and that's it for this unit. Oh, actually, one more part. And this is just going through what we had talked about before. If you look at the bottom here, for the most part, any compound that has OH in it, unless it has carbon in it, is a base. So if you look at it, we know that water, of course, would be an exception, because you can write it as HOH, but it's not a base. This is an alcohol, so this would not be a base. This is an organic acid, and we don't worry about this yet. It looks like a base because it has OH in it, but remember, it doesn't have a metal. It has carbon, so it is not an alcohol. It is not a base. Methanoic acid is an organic acid, and we'll talk about this in lesson, I believe, 11. So basically, for the most part, bases have to have an OH with a metal. If they contain carbon, they are not a base. And that is it for this lesson.